Good morning. Today we are going to, in this first video, we're going to check the work from yesterday. So you're going to need your notes, periodic table, and the polyatomic ion chart. Okay, so the first example that I will check from yesterday, problem number 1. All right, problem number 1 was sodium chlorate. All right. Looking at this is regular sodium. It comes from group 1, so it's written as what does it need? I'm sorry, what does it have? Right, the next one is chlorate. So I know from the ending that it's a polyatomic ion. So I'm going to go to the chart and I'm going to look for chlorate. And it's all the way down here at the bottom. Chlorate. So the ion is ClO3. And its charge is 1 minus. Okay, so it's ClO3, and its charge is 1 minus. Okay, so what I mean by are the charges the same? Well, this is a positive or negative 1, and this is a positive 1. But numerically, they're both the same, 1 and 1. So all we do when the charges are the same, we don't write the charges, and we just put the ions together. Now, this whole thing is chlorate, so I can't change it. So what is chlorate? Well, chlorate is a chlorine that has 3 oxygens on it. And that whole thing, that's why it's a polyatomic ion, is chlorate. So I can't change it. If I take away the 3, it becomes something else. And that's our takeaway lesson, is you can't change that subscript on a polyatomic ion. All right, number 2 was calcium carbonate. All right, so calcium is written as, what does it have? You can find calcium in group 2 of the periodic table. And then I look and I have carbon 8. 8 lets me know that it is coming from this chart. All right, so carbonate is right here. Carbonate. So carbonate is CO3 and its charge is 2 minus. Okay, so I have CO3, that's carbonate, and its charge is 2 minus. So once again, the charges are the same. We have a 2 and a 2. So I just drop the charges and I write the symbols with the subscripts. So if this is starting to make a little bit more sense and you want to pause the video and try the rest on your own and then check it, that's fine. All right, so this is iron 3 phosphate. Some of you expressed in this one doc that you didn't know where the numbers were coming from for these guys. So iron has a charge of 3 plus. Where did I get this 3? Well, I got it from this Roman numeral right here. And this is phosphate. All right, so we have an 8 ending. You might have to hunt for this one a little bit. Phosphate is here. Phosphate is PO4. And its charge is 3 minus. So once again, the charges are the same. So we're just going to drop the charges and write the ions. And I have to write this 4 because it's part of the polyatomic ion of phosphate. All right, the next one that we have to check is potassium acetate. And I just realized I think I chose everything that ended in 8 for the most part. All right, so potassium is K. It's in group 1, so it has 1. Acetate is up here, and acetate looks kind of funky. It's C2H3O2. So acetate looks like this. There's my 2 C's. H, another H. I think it's OH, and that's where its negative charge comes from. I'd have to double check that. So it's a big polyatomic ion. So it's C2H3O2. So that whole thing is acetate, and it has a charge of 1 minus. Well, we have a positive 1 and a negative 1, so I just drop the charges, and I write the whole thing out. Our last one that you had yesterday was lithium cyanide. All right, so lithium is found in group 1. And cyanide, even though it ends in IDE, there's no element that is cyanide. So cyanide is right here on this chart. And cyanide looks like this. It's a carbon that's triple bonded to a nitrogen. So this whole thing, this whole thing is cyanide. So it's CN1 minus. All right, once again, our charges are the same. So I just drop the charges and I write the symbols. Okay, you will have an opportunity to do more practice today. So if you're not quite understanding it, I'm going to do another video, and the only way you are going to understand this is to identify where you're struggling. So some of you might struggle with, I can't even find this ion on the polyatomic ion chart. That's really easy to solve. You just got to practice looking for them. My high school chemistry teacher made us memorize every single polyatomic ion. Was it helpful? Yeah. But I didn't remember them until I started teaching chemistry again. So I'm not going to make you memorize those, but if you're not understanding them because you're too lazy to look for them, that can be fixed. All right. So I'll provide you an opportunity to give me some feedback today on, what parts of this you need help on. All right. There's one more video coming up that you guys need to watch. Thanks.